All right, so today we are tackling a huge topic, one that's changing our world faster than we can keep up with it: artificial intelligence. Let's just dive right in.
I mean, we hear about AI all the time, right? It's in our phones with Siri and Alexa. It's in our cars trying to drive themselves. It's everywhere. But if you stop and think about it, what are we actually talking about? What is AI really?
You know, the best way to get our heads around this is to cut through all the noise, all the hype, and just look at the core idea. Because at its heart, AI has a surprisingly simple meaning.
The name itself is the biggest clue. Artificial? That just means it's man-made. Intelligence? Well, that's thinking power. So you put them together and you get a man-made thinking power. It's that simple. It's technology that we build to try and copy the one thing that we humans do best: think.
And this is really the key difference. On one side, you've got us, humans, with our natural, biological ability to learn and reason. And on the other, you have the technology we build to simulate that very same ability inside a machine. So one is born, the other is built.
Okay, but here's where it starts to get a little bit complicated. Thinking isn't just one thing. So if you want to build a machine that thinks, you first have to figure out what kind of thinking are you trying to copy. And this problem led researchers to a really brilliant framework.
They basically broke the problem down into 4 different categories. And it all boils down to 2 big questions. First, what's our goal? Are we trying to copy how humans actually think, with all our biases and weird quirks? Or are we shooting for perfect, flawless, logical thinking? And the second question is, how do we know if we've succeeded? Do we care about the internal thought process or just the final action we can see? This gives us 4 completely different goals for AI. You could build an AI that thinks like a person, or one that just acts like one. Or you could build one that thinks perfectly rationally, or one that just acts rationally to get the best result. Each one of these boxes is a totally different journey.
So let's zoom in on that acting humanly box for a second. This is where you find probably the most famous idea in the entire field of AI, the Turing test. The genius mathematician Alan Turing basically said, look, let's stop worrying about whether a machine thinks and just ask, can it act so much like a human that we can't even tell the difference?
And the test itself is beautiful in its simplicity. You have a person, an interrogator, typing questions to 2 mystery contestants that are hidden from view. One is a person, the other is a machine. And based only on the typed answers coming back, the interrogator has to guess which is the computer. If the machine can fool the human, it passes. So notice, it's all about behavior. It's not about consciousness or what's going on inside.
Okay, so we've got a handle on how an AI might think or act, but we also need a way to classify them by how capable they are. And that brings us to this really important difference between what we call narrow and strong AI.
Think of it like a ladder. On the very first rung, you've got narrow AI. These are the specialists. They're designed for one single job, like playing chess or identifying a face, and they are often way, way better than a human at that one thing. The next step up the ladder is the big goal, general AI. That would be a machine that could do basically any intellectual task that a human can. And at the very, very top, the theoretical peak, is strong AI, a system that could outperform us in many, many areas.
But this, right here, this is the most important thing to understand about where we are today. Every single AI that exists in the world right now, from the GPS in your car to the most advanced chatbots, is narrow AI. We are incredible at building these powerful specialists. But that truly flexible, human-level general AI, that's still a goal for the future.
So if everything we have is narrow, how do these systems actually think? We can break them down even further into a few different types based on what they're actually able to do.
The most basic systems are what we call reactive machines. They just see what's happening right now and react. They have 0 memory. Think of a simple chess computer that just looks at the board and makes a move. A step up from that is limited memory, and this is what most of the AI we use today is. A self-driving car is a great example. It uses recent data like where other cars were a few seconds ago to make decisions. The last 2, well, they're still science fiction for now. Theory of mind AI would understand human emotions and intentions. And self-aware AI, well, that would have its own consciousness. We are a long, long way from that.
So why have we gone through all these different definitions and categories? You might be thinking, this is a lot.
but it's because having these tools helps us make sense of what's really going on in this wild and crazy field.
Because at the end of the day, AI isn't one single monolithic thing. It's a whole framework for exploring intelligence itself. Understanding these differences, knowing if an AI is trying to act human or act rationally, if it's a narrow specialist or a future generalist, that's what lets us really understand its purpose, its potential, and, just as importantly, its limits.
And that leaves us with one last big thought. This whole quest to build an artificial intelligence, it forces us to ask these deep questions about our own intelligence, our own minds, our own consciousness. What does it really mean to think? In trying to build a mirror of ourselves, we might just end up understanding ourselves a whole lot better.